Good afternoon, students. Today I'll come with another topic. This is a new chapter. Your coding class or syllabus for coding is completed. So now you have a new topic, that is information theory. So the topic which will be covered today is what is information and its type, the different types of information. Then a simple block diagram which depicts the communication system. Then concept of uncertainty, measures of information, and lastly some properties of information and their proof. So first you should know what is an information. Information is associated with data, as data represents values attributed to parameters. Information is data in context. It is the intelligence or ideas or message which is to be sent from one location called source and to other location called destination for communication. There are four types of message which can be sent through a communication system. First one is electrical, means voice or current, voltage or current. The second one is speech or voice signal. Third one is picture or image, and last one is audio or video signal. In any type among these, in any type of or in any form, a message can be sent from source to destination. The figure depicts a simple block diagram of communication system. The information or message here is produced or generated from the source. After that, it is transmitted from source to destination through various block or various unit. For example, the first one is encoder. The total process and the unit which is used for information transmission is called communication system. If we draw a simple communication system, the source is the unit which generates information, then it is converted to a suitable form for transmission. The unit which is responsible for the task is called encoder. Then for long distance communication, transmitter is used. That means if the communication is done via a very long distance, then transmitter is required. The information is sent to destination through a channel. At this site, the information is again converted into its original form by the unit called decoder. Sometimes it is also named as receiver. Finally, it is sent to its destination. So it is the block diagram of a simple communication system. Now comes the concept of uncertainty. Uncertainty is the condition of an event before it occurs. Suppose a student gives an exam. Now, before publishing of its result, the student is not sure that whether he passes the exam or not. So before result, the condition is called uncertainty. Now, suppose after publishing result, the student gets the news that he passes the examination in a very well manner. That means after occurring the event, the students now get the information about the event. So that means an uncertainty is the condition of an event before its occurring. If an information is denoted by X, which is a fixed set of alphabet, X0, X1 up to Xn, and its occurring of probability of occurring of this alphabet is P, where P equals to P0, P1 up to Pn, where P0, P1, P2 all are the probability of occurrence of x0, x1 up to xn. Now, from the theory of probability, we know that summation of all these probability should be equal to 1. That means all these probability, if we added them, it must be 1. Now, when the probability of occurring of an event is increased, its uncertainty is reduced. That is, when P0 equals to 0, it has a high level of uncertainty, and its value when increasing, and as it reaches closer to 1, its uncertainty is reduced. If we say the probability of occurring of an event is P equals to zero point 0.1, then there is a high uncertainty of occurring this event. So, in short, we can say when the probability of occurring of an event is very low, then its uncertainty will increase. And you can say the event is very uncertainly occur. And whether it is when the event is already occurred, then we can say that we get the information and there is no uncertainty. Now comes the concept of measure of information. It is the information contained in the message. Consider an information source emitting independent messages m equals to m0, m1, m2 up to mn with a total probability of 1, where p0, p1, p2 and up to pn is the probability of occurrence of the message m0, m1 up to mn. Then the amount of information is given by the following formula: ik equals to log 2 1 by pk. P is the probability of occurrence of all the event. To calculate these, as we know that log 2 is not given to our calculator, so if we calculate this term, we have to use another formula, that is log 2x equals to log 10x by log 10 2. The unit of information is called bit. You should remember the topic because further it is required. Now we will discuss some properties of information. Here we will see there is 4 properties associated with information theory. Also we discuss the proof of each property. The first property is, if there is more uncertainty about a message, it means information is more. The second one is, if the receiver knows the message being transmitted, then information is 0. That is, if the probability of occurring of an event is 1, then information of this event becomes 0. Third one is, if I1 is the message of M1 and I2 is the if I1 is the information of message M1 and I2 is the information of message M2, then combined information carried by M1 and M2 is I1 plus I2. And fourth one is, if there are m equals to the power n equally likely message, then the amount of information of each message will be of n bits. Equally likely message means the probability of all the message bits will be same. The probability of occurring of all the message bits will be same. Now we solve first proof of our property. Property 1 say, if there is uncertainty about message, it means information is more. Suppose there is two information with the probability of occurring M1 equals to 1 by 4 and M2 equals to 3 by 4. Now we know that the higher probability of occurrence denote the lower uncertainty. Hence, uncertainty of message 1 will be greater than uncertainty of message 2. It is denoted by UM1 greater than UM2. Now, if we prove information in M1 is greater than information in M2, that is IM1 greater than IM2, then the property is proved. Now, let's find the information in M1. For calculating this, we use the formula that we discussed previously. IM1 equals to log to 1 by Pk. The value of Pk is 1 by 4. So, by putting the value, we can get the value, ultimate value, IM1 equals to 2. Similarly, we can calculate IM2 by using the formula. See the formula? It is the process of calculation of any information contained in a message. So, IM2 is equal to 0.415. Now, we can see 2 is greater than 0.015. Hence, information contained in message 1 is always greater than information contained in message 2. Consider to second property. If the receiver knows the message being transmitted, then information is 0. So let probability of occurring an event is 1. That means Pk is 1. If the event is surely occurred, then we can say its probability is 1. So information contained in this event is Ik equals to log 2 1, because here p value is 1. Because we can say the event is surely occurred, hence we can use probability of occurring that event is 1. By putting the value, we can get the information contained in the message is 0. So it is also proved. Now comes to property 3. It says if I1 is the information of M1 and I2 is the information of M2, then the combined information of M1 and M2 is I1 plus I2. Let's occurring of message M1 probability is P1 and that of M2 is P2. So information contained in I1 equals to log 2 1 by P1 and I2 equals to log 2 I by 1 by P2. Since M1 and M2 are independent, hence composite probability of M1 and M2 equals to P1 into P2. This is the composite probability. So I of 1, 2, that means information contained in the composite probability due to this composite probability is log 2 1 by P1 into P2. If we solve this, we can see that 1 by P1 log 2 1 by P1 into P2 can be represented by this, because we know the formula log 2xy equals to log 2x plus log 2y. By using this formula, we can also represent this formula by this way. Now, if we represent it, that means 1 is log 2 1 by P1 plus log 2 1 by P2. Now see, this term is the information contained is in message M1 and this term represents the information contained in the message M2. So we can say I12 equals to I1 plus I2. The next topic will be discussed in your next video.